guys, today I'm going to help you explain the LeetCode problem of finding the maximum depth of the binary tree. So here's our test case. We have 3, 9, 20, 50, and 7. Obviously we want to return the height of the tree, so as we can see there's 3 levels of this, 1, 2, and 3. So height should return 3. So how we want to solve this problem is we want to set up a queue, which is a data structure which follows the principle of the first one, first out technique. So what we want to do is first initialize the queue. You can say queue right here. And what we want to do initially is add a level of height to each section as we run through a loop. So what we're going to do is first we're going to add the root to the queue. So we're going to add, let's say, root dot append is equal to 3. And after that, what we want to do is remove anything that's in it from the left side each time we run through a level. So how we're going to do this is, instead of this, let's initialize what we have. So what we're going to do first is set up our DQ. So Q is equal to DQ. And what DQ is, meaning you can remove the left side of the queue and the right side. So the front and the back of it. So after that, we're going to add the root to the queue. So if root queue.append root. So that adds the root to the queue. So what we have here is 3, and the root is in the queue. Okay. And after that, we want to initialize our height. Say height is equal to 0, and then we set up our loop. So let's do while there's still something in the queue. We're going to set and then set up another loop for I in range of length of queue. So that means we're going to run a couple iterations for how many sides of how many lefts and rights each node has. Then we're going to set our pop left to pop the left side or the front side of each queue. The node is equal to pop is equal to queue dot pop left. Then we're going to do if node dot left. We're going to add the left side of the queue to the queue. And we're going to keep doing that for the right side. But at the end, we're going to add 1 to our height, and then return the height at the end. How this works is, let's say first this example, we had 3. We added 3 to our queue. So while we run the loop, the while loop only runs if there's something in the queue. It stops when queue is empty. So when we run this, the length of the queue is 1. So length is 1. And this pops the queue. So if we have here, our queue will be empty. And then this will add the left side of the root. So now we have 9. And if we have the right side, we have 20. And then we add 1 to our height. So our height will be 1. And then we run this again. So our length is now equal to 2. We pop the left side. So we have 20 in our queue. And then we go in again. And there's no, from the left side, there's no left or right. So we run it again. Now there's 20. We pop it. So now there's nothing in it. So now we add our left side and right side. So we in our Q, it's 15 and 17. That's the end of it. And we add one more to our height. So our height is equal to 2. Then we have to run the for loop 2 more iterations. So back to it. We pop the left. So now we have 17. Now we're looking for the left to right of the 15. And it's null because there's nothing connecting it, so it's null. And now we run it again. We look at the 17, there's no left or right to the 17, it's null. So we pop this, it's gone. Q, we add one more to the height, so height would be 3. Since the Q is empty, the length is 0, so we go back to here. There's nothing in the Q, so the while loop stops. And we ended up with the height, which is 3. Pulled up maximum depth of a binary tree, and just like in our whiteboard example, we're going to solve this pretty simply. We're going to set up our Q is equal to dq, and after that we're going to add the root to the Q. So do Q dot append, add root inside, initialize our height, which is equal to 0, and then we'll set up the loop while Q is present for I in range of the length of the Q. And then we're gonna set up our pop left is equal to Q dot pop left. We're gonna do if node dot pop right, if node dot left, Q dot append node dot left. Same thing for node dot right, Q dot append, node dot right, height plus equal 1, return our height. This should run now. If both test cases work, we can go ahead and submit this. 3-second runtime, and that's all there is to it.